Welcome dear students, welcome to the lecture of automata theory. Here today topic that we are going to learn is on regular grammar. Regular grammar is a grammar that is understood by any of the finite automata and for which the language that we follow is a regular language. Okay, so regular grammar we can say is coming in two types. It is of either left linear grammar or a right linear grammar. So what is exactly a left linear grammar? Left linear grammar is a grammar in which we have a rules given as this. So if you observe properly in this rule, say for example on the left hand side we will always have one capital letter. Okay, so this capital letter on the left hand side, so any capital letter that is coming we call it as a non-terminal. So non-terminal is something which is a capital letter. We also call it as a variable. So a left linear grammar is something in which we have a single variable on the left hand side, and on the right hand side what do we have? We have a single variable coming and then followed by any non-terminal. So non-terminal is any terminal is any small case symbols. Okay, so here in the left linear grammar what do we say is the only constraint is on the non-terminal that is coming on the right hand side. So on the right hand side we should have exactly one non-terminal, or we can say maximum one non-terminal. Okay, so here I have one non-terminal, here I have one non-terminal, here I have zero non-terminal. So all these rules are allowed. Yeah, and the non-terminal if you are having in your rule, say like this, if you are having a non-terminal, make sure the non-terminal appears as the leftmost symbol in your right hand side. So here P is also a leftmost symbol in the right hand side. Yes, so I can say this particular rule A giving capital B A is also a left linear because the non-terminal is appearing as a leftmost symbol. But if I say A is giving AB is not a left linear. Why? Because here the non-terminal is coming on the right hand side. So if I have any non-terminal, it should exactly come on the left side only. So I hope you are clear with the left linear grammar. Now let's go and see what is a right linear grammar. So right linear grammar is a one exactly same way but the opposite. So if you have a non-terminal, that should be coming as a rightmost symbol. So here I have a non-terminal which is coming as a rightmost symbol. Here I have a non-terminal which is also coming as a rightmost symbol. So the last symbol in your production should be the non-terminal. If that case is followed, then your grammar is proper. So we know what is a regular grammar, that is a left linear grammar and a right linear grammar. So now let's solve some questions on it. Okay, so now the question is given as, given a right linear grammar, derive the string 001, 222, okay, also generate the parse tree for the same. The grammar is given as follows. Now the first step that we do is, we will write all the rules separately. So this way I have written all the rules separately in this form. Okay, so I have numbered them from 1 to 6. The numbering of the rule is really very important when you want to derive the string. Okay, now let's try to derive the string for the given grammar. So now to derive the string, I should first start with the start state only. Now which variables are the start variable? Only S is a start variable. So I can basically start with any of the first two rules. Okay, now it's all up to me which rule I have to choose, but I have to choose the rule wisely so that I should be getting the string 001, 222. So now if you just see, I want to start with 0, so I think I should go with the first rule, and that's why I'm going with S giving 0S. So here I'll write down using production rule 1. So every time I'm substituting some value, I have to write down the rule number. So using production rule 1. Now for this capital S or the non-terminal, I am going to substitute the value in the next step. Again I want the next symbol to be 0. So I think I should go with the first rule again. And what I'm doing over here is S giving again 0S, that is again using production rule 1. Now for this S, I can put some other value because now next symbol that I want is 1. As you can see here in the string, the next symbol I want is 1. So as giving A could be a better option. So I'll go with the as giving A. Okay. And that is using production rule 2. Now for A, I have 2 rules, but I will go with the third rule because it is starting with 1 and I want to get symbol 1 there. So I'll say A giving 1A. Okay, that is production rule 3. Now here for this A, I want now the symbol to be read as 2. If you look at the string, I want to read the symbol 2. And to read 2, I think I should go to B and I will go with the rule A giving B. So A giving B is a rule number 4 that I have used just now. Next step, I am substituting the value for B. For B, I have 2 production rules. Which one should I be using? Because I want to read the next symbol as 2. So B giving 2B could be a better option. So B giving 2B. Now that is using production rule 5. Again, I want to read 3 times totally. So I will be using the same rule 3 times. That is B giving 2B again. And for the third number of 2, I will again use B giving 2B. Now I have done with my string. I should be stopping now. So I will go with the rule B giving epsilon. That is just like that. And I have used rule number 6. So now we can see using the production rules in this combination, I got my string 0, 1, 0, 0, 1, 2, 2, 2 derived here. So now for the same derivation that we have done, so remember whenever it is a right linear grammar or a left linear grammar, we can derive the string only in one pattern. There is no leftmost or rightmost derivation. That is only one type of derivation. Because this is a linear type of a derivation, every time we get only one non-terminal symbol to be solved. If you just observe properly, here I get only one non-terminal. So every step you have only one non-terminal to substitute, and that's why there is only one method to derive the string. So now we have done derivation of string. We can do the derivation of string by this method or the other method, that is a parse tree. So let's try to generate the parse tree for this. Again for parse tree, I will start with the start symbol first. Okay, so if you see now, for this grammar, we'll again start with the start state, that is 0s. So exactly same way how we used in this this derivation method. First rule that we use is as giving 0s, then as giving 0s. So here as giving 0s, again as giving 0s, okay, and as giving, okay, so I modified this to as. So as giving 0s, then as giving 0s, then as giving a. Okay, so now this is the proper tree, that is as giving 0s. Next is as giving 0s. Next as giving a. As we can see here in this particular, here we are using rule number 2, that is as giving a. Then a giving 1a, that is rule number 3. So a giving 1a. After that a giving b, that is rule number 4. A giving b. And then rule number 5 coming 3 times, that is b giving 2b. That is b giving 2b coming 3 times. And at the end I am using rule number 6, that is b giving epsilon, here b giving epsilon. So here at the end, if I look at the parse tree, the string that I have generated here is, I have to write this in the in-order traversal. So I have to write the statement, that is string derived by parse tree is 0, 0, 1, 2, 2, 2. So we have to make this statement at the end of the parse tree. And this way we are done with this particular example. Hope you have understood. Okay, so in the next video we'll see the other way, that is using RLG. Thank you for watching.